PCA, Principal Component Analysis, is a mathematical technique that helps us simplify complex data. Like many mathematical concepts, it might sound complicated at first, but don't worry, the idea behind it is actually very intuitive. Imagine you are a photographer with an important job, capturing the perfect football team photo. From the side? No good, players block each other. From below? Too dramatic and we lose the team formation. From behind? Well, that's definitely not what we want. But then you find it, that perfect spot right in front of the team. This is the perfect angle to capture the maximum amount of information in a single shot. PCA does exactly the same thing with complex data, but using mathematics. First, PCA finds the direction with the highest variance in the data. The amount of variance captured in this direction is called an eigenvalue. In this example, let's say it equals 3. Then, it identifies this direction as an eigenvector. This becomes our PC1. Next, it finds the second highest variance, eigenvalue equals 2, and its direction, eigenvector. And finally, the third. If we take the photo using the two directions, principal components, with highest variance, we'll get the best possible photo, even though we're ignoring some information, in this case, the depth of the players. We can ignore the less important details, making our data much simpler to understand. In other words, PCA creates a new coordinate system based on the data's variance. The eigenvectors become the new axes, and when we project our data onto these axes, we get new coordinates, also called scores. This seems straightforward with 2D or 3D data. But what happens when our data has hundreds or even thousands of dimensions? A spectrum is a collection of data points, where each point measures how something responds at different frequencies. Each point represents a dimension, and when we trace a line connecting them, we create a spectrum. With multiple spectra, understanding the underlying patterns becomes challenging. By applying PCA, we can condense the important features into a single graph, enabling us to clearly define distinct groups of materials. Applying principal component analysis, PCA, can be challenging if you lack coding experience or don't have access to specialized software. That's why we created Spectrify. Spectrify is a web-based tool that makes spectral data analysis simple and accessible from any device. Let's walk through analyzing a dataset together. In Spectrify, we have loaded different test datasets. Let's explore one of our preloaded workspaces. For this demonstration, I'll use the Indonesian ground coffee classification dataset, which is based on the research paper linked in the description below. In the metadata panel, you can view information associated with each spectrum, including coffee type and other variables from the original research. To optimize our analysis, let's select all spectra and apply two pre-processing steps: standard normal variate, SNV, normalization, followed by smoothing. Now, with all spectra selected, navigate to the Machine Learning tab and click PCA. The data will be processed instantly. By selecting the type's metadata, we can investigate whether the coffee varieties form distinct groups. For guidance on importing and pre-processing your own data, check out our tutorials on our YouTube channel. Spectrify, making spectral analysis accessible to everyone.